Good afternoon, ladies and gentlemen. The webinar is beginning. Normally, my president CEO, Stephen Love, would be here to provide the intro, and he was called to Austin, Texas. He has a meeting with THA, so he sends his apologies. My name is Chris Wilson. I'm the communications director here at the Dallas-Fort Worth Hospital Council, and thank you for being here today for this webinar hosted in coordination with CitiusTech. They are an associate member of the council, and they just came aboard recently, and we're looking so forward to working with them. Today's topic is Pragmatic Approach to GenAI. This is a timely topic, and we have a great turnout today. In today's rapidly evolving healthcare landscape, the integration of innovative technologies such as generative AI or GenAI is becoming essential. The challenge lies in balancing innovation and practical constraints. We have two national speakers to discuss this topic today. They are John Squeo, a Senior Vice President, Provider Segment at CitiusTech, and Dr. Kaushik Raha, President, AI Solutions, Vice President, AI Solutions at CitiusTech. Before we begin, we'd like to note we will be taking your questions. If you could type them in the question or chat box, we will answer them before the end of the presentation. And with that, ladies and gentlemen, I'm really looking forward to this. Here's John Squeo. John?
Hello. So what we're going to talk about today is a topic that is quite steeped in mystery to a lot of people. What we want to do is take both the business side of it and also the technical side of it, because we know that there's multiple of you in the audience who have different disciplines out there, both technical and digital, and also clinical and administrative. And so what we're going to try to do is tell this from the business perspective about some of the challenges with adoption, give some real life use cases. We're going to start off with that, in fact. And then Kaushik is going to go into some of the technical aspects of it, which I think we're going to keep it simple enough to where we're going to try to bring everybody along that may or may not be comfortable with this work, and also hopefully challenge and bring up some key insights for some of you that are steeped in artificial intelligence. So with that, I'll just kick it off here. I'll just give you a quick background of who I am, and I'll let my colleague Kaushik Raha do the same in a moment. We're going to talk about streamlining labor-intensive workflows, which is where we're going to get into the use cases and how you might think about adopting those. And boy, we would love to hear the feedback of how you might already be experimenting, or some of the big boulders or challenges or benefits and bright spots that you may have already encountered. And then Kaushik is going to really take it over from there and talk about the technical aspects and then some key considerations that you ought to think about. So just here at the top, myself, I am the leader of the market that specifically targets and helps our customers in provider systems. That's pretty much every licensed facility and provider networks out there, and even the suppliers of the providers. Some of the key things that we work on here at CitiusTech is artificial intelligence, advanced analytics, business intelligence. That's the basic, Tableau and Power BI, Slicer, Dicer, and Epic that you guys work with. And then we work heavily with getting data in and out of many claim systems, EMRs, and then doing a lot with that data. So a lot of interoperability, a lot of data, enterprise data warehouses and data management and such. The other thing that we do is Salesforce and customer experience. So there's all kinds of things we bring today, but we're going to specifically touch on AI and how to do this effectively, efficiently, but most importantly, sustainably. Here at CitiusTech, we only do healthcare information technology. We don't focus on any other industry. And as part of that, we take a very pragmatic approach, because we know that there's not a lot of resources with our reduced reimbursements and low margins to fail on experiments. There's just really not a lot of discretionary opportunities out there. So what we try to do is bring very essential types of use cases that we know and already have proof can be significantly enhanced using some of these technologies. And then we apply repeatable assets that we bring in the door when we try to bring that, so that it makes your investment much, much more efficient and lower risk. So on that, I'll turn it over to Kaushik to introduce himself.
Hello, everybody. It's great to be here with you, and thanks for the invitation. So I'm Kaushik Raha. I'm the Vice President and Head of AI Solutions at CitiusTech. So at CitiusTech, me and my team are focused on building horizontal solutions using AI and generative AI, which are applicable to different markets, such as the payer, provider, life sciences markets, and so on and so forth. Um, I have about 20 years of experience in the healthcare and life sciences sector, focusing on digital transformation, machine learning, deep learning, artificial intelligence, and now using generative AI to improve, bring in the technologies to improve health outcomes and patient outcomes. So with that, I'll just turn it back over to John.
Hey, thank you, Kaushik. Let me advance here. Okay. So we'll just jump right into a use case as I had promised. So one key use case that keeps coming up is helping organizations deal with denials management. I'm not sure if that's a pain point for you. I would suspect that there's a certain level of maturity of dealing with that in every organization, and it really is on some batch of claims with payers, and particularly with some practice management or EMRs, it might be really good. And then in some other niche that you might have, it might be challenging. So we see that kind of multimodal challenge very frequently, where you've got some things working really good and some things that can use some help. But at the end of the day, we would love to get denials down. But there's a recognition that the payers are using this heavily, right? They're using this technology. They've implemented it. They've implemented it very well. We help a lot of them do that as well. And it is a challenge, right? So what's the most important part of it is precision. We have to make sure that if something is legitimately going to get denied, that it's legitimately deniable. And more conversely, on the revenue integrity side for provider systems, which is where, near and dear to my heart, we have to make sure that we're getting paid for everything that we've done. And that means trying to adapt to the phraseology, to the key documents and the key words that we need to do to make sure that claim goes either clean, or at least we can get it paid through a appeals process. So a lot of you may ask, what does this have to do with denial management? Well, as you know, a lot of our tools, particularly whether you're an Epic or a Cerner or a Meditech hospital, or you're on a different EMR, a lot of them have pretty good tools within the practice management tools to be able to do this. Certainly, we use scrubbing technologies on top of that, whether that's from 3M or other parties. But more importantly, it's the process where things get dropped. It's the handoffs of actually getting the documents in and passing them through the entire value chain to get to process that denial and then make an appeal, and then repetitively doing that until you've refined it to where it will then get reimbursed. So the key thing is we were doing a lot of this via robotic process automation, and that's just basically RPA, where you mimic human movements of the mouse on a screen to do all of those workflows. And we said, look, that's all great. We can do that with that. But then what about generating the appeals letters? And that's always been a human thing. We've never really thought about doing that with technology, but this has unlocked the ability to do that. So, if you look at the problem use case that we're going to go through in a minute, denial processing, as I point to number one here, it's about, it's a significantly manual process. When we think about the entire process of having to go fetch a denial, get it into a significant ones into a basket, examine them, identify what's wrong with it, and then go ahead and attempt to remediate, and then is essentially appeal. And then to do that process iteratively if necessary. And then obviously through that entire process, 2, 3, 4, we get into situations where it's very complex for RPA to handle. There's obviously specifics that would be good to know about how we might respond to that appeal with each individual payer, that they have different nuances when they did the adjudication. So these are things that we're seeing down below, I'll say, measuring efficiency. There's situations we're getting into where GenAI powered claims review can reduce denial rates between 10 and 30%. Now that's a real number that we've seen. And so the key thing is, if these are expensive claims, that can be a significant amount of dollars, as you all know. It certainly justifies the investment, as we've seen. 2 years ago, and even 1 year ago, the investment was very high. The burden to create this technology was substantial. What's happened in the last year is the cloud vendors that a lot of you have heard of, Microsoft's Azure, Google, AWS, they have encapsulated enough of this technology to where we can quickly build on it, and then we can add tools that we've honed with other major provider systems and payers on top of that to radically reduce the investment necessary to do specific use cases, and therefore quickly capture that kind of gain. So here's an example, right? So if you have these manual interventions, and then you have the denial review time, and then obviously it's exceptionally difficult to go into these different systems. Oftentimes they require credentials, passwords, usernames, etc., to fetch the information. Oftentimes you have one person doing that for, instead of having a more balanced approach. So it may be happening only in different parts of the day. It may be better with a particular person than another person that's doing this. What we're seeing is, as we've set up these capabilities, it really takes the best practices of your entire CBO or your entire revenue cycle team, and we scale up everybody's ability to do it. We actually take a lot of the work that's mundane about fetching data, et cetera, and then putting it through and then generating an appeal. And we do that with AI, thereby allowing your people to actually get the wording right and to work with the clinicians to make sure that that documentation gets into where it needs to get into, to be able to better justify even to clinicians if necessary why we need to put that in there. So this is the kind of unlock that we're experiencing with this kind of a solution. I'm going to just breeze through a couple others, and then I really want to get into the technology, and then we want to open it up for questions along the way. One that is very powerful that we've seen is IT support help desk, re-engineering. Now, why would this be interesting from a GenAI perspective? Well, I asked myself the same question, and I'll tell you a story. I was helping a chief strategy officer who's also a CDO of a major IDN, integrated delivery network, in the mid-Northwest, and he said, help me use this GenAI with my help desk. And I said, well, that's not a very exciting use case. And he said, well, let me tell you what I really mean. He said, help me get my nurses and my doctors off the phone with IT support as quickly as possible, and don't worry about anybody else in the hospital. Just get them off the phone and back to work when something breaks, or get their tickets resolved that they've put in. I said, okay, that's interesting. So what we did is, through a little assessment, we were able to identify through their ServiceNow trouble ticketing system that the majority of the tickets that were impeding doctors and nurses from working were related to certain modules. In that case, what was within Epic, and a few other ancillary systems. And we said, let's just focus on that. And let's make our system really smart at giving great advice to the help desk people on the front line on how to resolve problems that we resolved in the past. What this ended up doing is, if you take how it kind of works is, we take Dr. Patel, he's faced an issue and he submits a request, or he has his MA submit a request. And then Ben, who's the IT support technician, analyzes the request, categorizes the issue, and then assigns it to someone that can actually do the work, right? Very typical, happens every day. And then maybe that IT support tech who it was escalated to, she looks at it, she resolves the issue, maybe, or she might be able to need to continue to pass that ticket along until it gets to the right person that can actually identify a solution. And then it goes back, and then ideally we can contact the doctor or whoever their assistant is to resolve the problem. Imagine the future state, which actually is not future anymore, it's actually in production, where the ticket is auto-created via email or message or chat, just like a human could take it on intake. I mean, this is very, very conversational. And then that what happens here is we get on with an actual human tier one help desk person who really does not have knowledge about a lot of these backend systems. In fact, they're quite arcane to them. They typically just fetch and then pass that ticket along. But in this case, we're going to give them some power at their fingertips. because we've resolved most of these tickets in the past, and that's somewhere in our CMDB or somewhere in ServiceNow or ITSM system, trouble ticketing system, somewhere in the past, we're going to tap that information and bring it to the fingertips of this first line of this first line IT support person so that they can get that doctor or that nurse off the phone quickly and get them resolved. How we're going to do that is just like ChatGPT, and you guys use it, today, or Google Gemini. When you go ahead and put in a prompt, it will give you a very expert answer back, just colloquially, that you can then use to go ahead and try to resolve the ticket. So that's what this is going to do. These people are going to be trained on some simple prompts, and we're going to have a little dictionary of prompts. So when Dr. Patel, in this case, now calls in, he'll say, hey, I've got this ticket, or I've got this problem, blah, blah, blah. That's what I'm seeing. My report's not running, whatever it is. And this person can put in a simple prompt like you'd put into ChatGPT. And what it's going to do is it's not only going to use the large language models that you all have heard about out there, but we're going to do something on the inside after he types, but before it goes to that large language model that's operating at AWS or Azure. And we're going to put some really interesting information from ServiceNow that's in your own enterprise system to that. So the information that comes back to that IT support person, it is an absolute expert answer. And we're seeing that. In fact, we're seeing upwards of 60% resolution, first call resolution on a couple key things that were causing a lot of bottleneck trouble tickets. And in this case, we also saw a 30% reduction in L1 and L2 ticket resolution altogether. So that not just the 60% for the ones that were the biggest bottleneck, but for the ones that were in the trouble tickets and the systems that we were trying to focus on specifically to get those nurses back to work quicker, there was an overall 30% reduction in those tickets, which was frankly remarkable. I would say that the one thing that we really learned is this RAG, which is a big word for using your own enterprise data to improve the prompt that you put in, that kind of ChatGPT prompt, improve that prompt before it's sent to the large language model. That is absolutely critical. Now that process is called RAG. It's basically saying, I'm going to put in a prompt that I know as a human, and then the system is going to just automatically going to enrich that with a bunch of different data from our own private system. And then we're going to get back an answer that is really going to be an expert. That is absolutely critical. As we do that, as we train this model, the subject matter experts are absolutely critical. And Kaushik's going to go into kind of how we do that from a governance perspective. Then we also know that you got to have the data. And one of the key things that we do on this IT help desk is we're going to tap your core sources of data and not everything. That might be your trouble ticketing system or your ITSM system. Sometimes it's even Outlook or Exchange and the emails, because some of the tickets are resolved within that. I'm going to keep going. Just a quick example of how we're seeing this more frequently used in production environments to enhance workflows utilizing generative AI. I'd love to pause here. Are there any questions that are coming in on chat, or does anybody have any questions they'd like to ask? Okay, I see a hand up. Brandon? Pasha, can you read off if that's there? Or?
Brandon, if you want to ask a question, you can type it into the chat box or the Q&A box.
Do we have a question coming?
Yeah, there is a question, John. So the question is regarding service desk numbers. Did that healthcare system already utilize ServiceNow help button with an Epic?
No, they're going that direction, but they're going to keep the system intact because, interestingly, a significant number of their of their tickets weren't even Epic issues. There was other systems that were impeding some of the different service lines and clinicians and allied health professionals within those different service lines. So while Beaker was a bit of an issue in their environment, they need this for a lot of the other apps that they're operating in. So this was kind of a central place where they could do that. But they are going, I mean, our guiding principle is if we can do it in Epic, let's do it there, optimize it, but then let's put in the other supportive capabilities that we need for everything else we got, and let's just put that in once. So, you know, and ideally we'd like to integrate them together, but there's always some pros and cons of doing that.
Yeah, that's the only question there is right now.
So let's move on to the technology component. We're going to, once again, we're going to try to keep this pretty level, but there's going to be some depth here. So I encourage you to jump in and ask basic questions, because we get basic questions from our CIO, CTO customers all the time, and that's the way we learn together. So Kaushik, over to you.
Yeah, thanks, John. So yeah, I'm going to start with the key considerations and guiding principles when building generative AI for healthcare. And at CitiusTech, as John mentioned, we are purely healthcare focused, and we have invested a lot in generative AI and how that can sort of help with healthcare and patient outcomes and so on and so forth. And what that's done is we have developed a lot of internal know-how and expertise and internal muscle, if you will, when it comes to not only sort of understanding the nuances of generative AI in the context of healthcare, but also building practical applications, solving practical problems for our customers who are, you know, providers, large medical centers, payers, and so on and so forth. So with that in mind, just move to the next slide, John, if you don't mind. As a result, we have the point of view, and what we think that in healthcare, GenAI is going to play a major role, and that's a given. But there is a timeline to this. What we think is going to happen in the medium term is different from what we think is going to happen in the longer term. And in the short or the medium term, there are things that are, I don't like the term low-hanging fruit, but there are a lot of use cases which are something like that, which generative AI will really transform. And one of them is search and information retrieval, which has been a major pain point for healthcare, for provider systems, for medical centers. How do you find the right information for the question that you're asking at the right time, at the right location? And I think that this is something that GenAI is gonna change, and it has actually changed a lot. But I think it has really gone to a point where it is completely transformed. The second thing I would say is communication and patient support. It's going to be a lot more personalized, a lot more interactive. And it's all because of generative AI. I mean, we all know about clinical documentation and how that's a burden on the clinician. A lot of that is going to be addressed with generative AI. That doesn't mean that handing over the clinical decisions to a model or AI. It really means that sort of the grunt work that clinicians, doctors, RN nurses are doing on a daily basis, they'll get a lot of help. Let's just put it like that. And also this idea of synthetic data generation, which has been a problem with even creating models. One of the biggest bottlenecks in creating models, AI models, machine learning models, GenAI models, is the data itself. And in an interesting way, generative AI actually is going to solve for that, because what it does really well is sort of synthesize new data, or generate new data, and which is synthetic in nature, which could be used for further sort of generation of models or fine-tuning of models, and really taking it to the next level. So it's almost like a loop that's there, which it'll help with. And obviously there's a automated code generation validation. This is more of an engineering thing, but engineering underpins healthcare in a big manner. So the more automation we get with code generation, with things like co-pilots or so on and so forth, the more value it brings to a healthcare enterprise. So in the longer term, our point of view is that there are quite a few things that are going to come to the fore, which is really going to change the landscape of healthcare. One of the things that we are envisioning is what are known as AI agents. You can almost think of this as any agent that you might have, might know of. It could be a customer service agent. It could be a nurse practitioner agent, or someone, a clinical reviewer. any of these functions, conceptually will in the longer term could be turned over to an AI agent, so much so that this AI agent could essentially handle that task, learn from their experience, make decisions in a completely autonomous manner. What this also means is that some of the clinical decision support or clinical decision making will also start moving over to AI and GenAI. And this is a little bit of a fraught sort of question, but there's a lot of governance and compliance and regulatory activities that need to line up for this to happen. But it will happen. It's a matter of time no longer, and that's going to happen. What we're also going to see is, building these foundational AI models, things like, ChatGPT, OpenAI's model, which is costing billions of dollars. Google spends billions of dollars. It's going to come into the realm of affordability to the point that it'll become very easy or very cheap to, build these models and deploy them as and when you need them. And we're starting to see glimpses of that already. The very latest news you're probably aware of is DeepSeek, this model from China that is actually as good as ChatGPT, but it's supposed to be built at a much lower cost and has much lower operational cost. So we are starting to see the beginning of that, but it's a trend that's going to accelerate to the point that you'll have really powerful models at a much more lower price point. Things like transparency, lineage, traceability, responsible AI, these are all like nice to haves in today's AI landscape, but we are not there yet. And because of that, it's deploying AI or deploying Gen AI is still quite fraught in the sense that it's very risky. But I think what we're going to see in the longer term is that we'll get a much more better handle on all of these things. We'll get much more better with transparency, with traceability, with explainable AI, and we'll have networks that are going to power this. And we'll talk a little bit about that. So yeah, I mean, I think that's kind of what we're looking at in the short term and the long term. And we at CitiusTech have been sort of putting out a lot of our point of views and white papers. And so I encourage you to sort of reach out to us if you want to learn more about this. If you move to the next slide, John. Yeah, you can stay there. So there are a lot of frameworks within generative AI, and it takes some expertise to figure out like what are the right frameworks. So there could be frameworks for the use case. There could be frameworks for the architecture. Suppose you want to build something for production and scale, and that's something scales from the get-go. You need to have an architecture framework. There could be a cost framework. What are the kind of problems that you're solving for, and you're cost conscious about these? So like, how do you optimize for that? And a whole lot of other technology frameworks. And what I've shown here is a use case based framework where you can where the question is like, what is the right language model for the right use case? And we have put some effort into thinking through these things. You can go down this flow chart or this this decision diagram and ask whether it's a clinical use case, whether it's a non-clinical use case. If it's a clinical use case, if it's just textual data, or if it's multimodal, where you could have radiology reports with images or pathology reports and so on and so forth. Or there are a lot of non-clinical use cases that are also quite important, and John was alluding to some of those. These could be operational nature, these could be commercial in nature, or it could be simply sort of technology-based, non-clinical solutions, which are very relevant in the context of healthcare. So depending on what your use case is and what your modality is, you can start to bucket the use cases into those, and finally you can break that down to the kind of tasks that are needed to solve for that. For example, if it's clinical research, we would want to do things like document Q&A. We would want to do search and summarization. We would want to be able to sort of do better knowledge representation so that we can improve search and QA and all those things. And these are in itself they're Gen AI tasks. Search, summarization, Q&A. These are all tasks that are handled by generative AI, by large language models. And so what we've done in our work is we have really sort of explored what are the right models for these use cases, for these Gen AI tasks. And some of them I'm listing here. Again, this is a little bit of dated slide. This is a very fast-moving field. So, the models that I've listed here are a little bit different. But you see the ones that are the obvious ones like GPT-4 and all. They're what you call state-of-art models, and they're very good at a lot of these tasks. But the other takeaway here is there is there might be some specialized tasks such as medical coding or tagging clinical notes with medical codes, and there are more sort of vertical models, if you will, which are specialized for these kind of tasks. And I think what we'll see more and more is that these really powerful models, but just to make a point here that the specialized vertical models that we have are fairly low capacity at this point. But I think what you're going to see, the transformation that's coming is you'll be able to create really highly sophisticated, highly specialized models for querying genomic data or for querying EHR data. So that's where we are going with foundational models, which are highly specialized, but they also have extremely powerful reasoning and planning sort of capabilities. But the bottom line here is that we need to have a framework for choosing what are the right kind of models and what are the use cases. And we have those frameworks internally within CitiusTech, and this gives you a flavor of that. John, you can move to the next slide. Yeah. And the final piece here, I would say, is the governance piece. This is all AI and GenAI, and what we have seen is that without a strong governance framework, without a strong framework for enabling or ensuring trustworthiness or quality of these models, they don't really go anywhere. So what happens is a lot of times people are just stuck in these pilots and POCs, and they don't know what to do past that because they don't have a structure or a framework for that. And for that, we have come up with a center of excellence type framework, which also aids in the governance. And for that, we kind of understand what are the key processes that are important. For example, it could be things like planning, project definition, things about regulation and compliance, operational questions. And within that, we identify all the components of of those processes. And then there is this operational model, which could be at the organizational level. So, for example, if you're a center of excellence, which is and your main goal is to procure the best generative AI software, that would be different from a center of excellence model, which is more innovation focused. So as an organization, you really need to understand what do you want to create the center of excellence for, and then you can pick the key processes and the components of what that might look like. And obviously, this is driven by the objective, like I said, if it's an innovation catalyst versus a procurement sort of exercise, or it could also be digital transformation or talent transformation. So depending on what are the key objectives, you can design a center of excellence, which essentially at the end of the day is a means for governing all of AI and GenAI. And at CitiusTech, we have done a lot of work towards this as well, where we're creating what is known as the AI Control Tower, which essentially is a framework that sits on top of any organization, and it gives guidelines and playbooks for putting this into action. Obviously, there are a lot of other components here, a lot of the stakeholders here that need to be taken into consideration. There could be business, legal, regulatory, and so on and so forth. But we at CitiusTech have been devising this AI Control Tower, which essentially would be a governance framework for the COE. If you go to the next slide, if there are no questions, and please feel free to...
So question for you, Kaushik, as we discuss, and I'd love to hear from the audience as well. This stuff is fantastic, but we know the large language models, they're out there at running at Azure, running at OpenAI, running in AWS. We don't want our own internal data, our enterprise data, to leak out to that, right? And to be used to train those models, which I know that's prohibited from them doing in the HIPAA BAAs. But how is it that we use our data to make sure that the conversational analytics that we're using this GenAI for is giving us the most kind of enterprise-specific information and answers to our own health system? Can you tell us what are we doing to make sure that our data is being injected into this so that we get answers that are relevant to our health system when we use this kind of ChatGPT type tools?
Yeah. So that's a great question. And in this slide, goes into a little bit of that. But before I even talk about this slide, there is this RAG, a concept of RAG, which is retrieval augmented generation. And that is one way to do that, is to make sure that the large language model is grounded or to the internal data that an enterprise might have. So what we do is, like John mentioned, that you just described, is you take a prompt and you enrich the prompt with the enterprise data. And RAG is a pretty basic way of doing that, which is very heavily used, but there are sort of higher level abstractions of this, and that's where a knowledge graph comes in. And what a knowledge graph really is basically, it's a network of all the knowledge that might be encoded into it. And this is knowledge, this is data that is proprietary. This could be part of your own organizations. And knowledge graphs have been around for a long time, but with the advent of GenAI and large language models, it has become very tractable to build these, maintain these, extend these. And what the knowledge graphs in turn do is they enrich the large language model, like by providing it proprietary information in network form, which can be easily sort of deciphered by a large language model to give an answer. So when knowledge graphs come in, is to make that large language model of generative AI application much better than you could find in the wild, right? So you are giving it your enterprise knowledge in a way that is very understandable by the large language model, and it's not sort of just constrained to one small piece of data or one small piece of information. It now has access to the entire, graph or network of information, which is relevant to the question or the task at hand. So that's why we have also at CitiusTech spent a lot of time, building knowledge graphs, and then creating generative AI applications which use these knowledge graphs. And in the context of healthcare, this has given us great results. What we are finding is, using knowledge graphs, we can do sort of multi-step question answering, multi-step reasoning. It understands medical terminology a lot better. For example, you could use like abbreviations like DCIS, ductal carcinoma in situ. It understands what it means. So these are the kind of things that a knowledge graph will help a GenAI application achieve. And the way to build that knowledge graph is to take all the data that you have in your organization and encode that or load that into a graphical or a network structure. And these networks are much more value add than your static data, which is residing in files or databases. So that really, the knowledge graph really is one level above that. And the benefit of knowledge graph is it makes your large language model a lot more smarter, even smarter than what it already is. So that's hugely important, but not more importantly, it keeps it grounded to the enterprise data, to the data that is your own, that's proprietary, and it doesn't let it sort of veer off in some other direction. So that's the way I would answer that, and essentially that's what this slide is also saying. And here I'm just giving you a use case for knowledge graphs, and clinical decision support is a big use case. What you want to do is initially to figure out what kind of graph do you need for the problem that you have at hand. And clinical decision support is a typical use case. A clinician at the point of care wants to maybe do a diagnosis, wants to maybe understand the differential diagnosis or the therapeutics or the medications. And once you encode all of that data into a graph that I'm showing in the screen, you can really traverse this from disease to therapy to medication to finding procedure, and then you can make connections with other sorts of graphs that are out there. And one of the things that we do is we make sure that medical terminology is also coded into these graphs. For example, ICD and CPT codes are part of this graph. So what you have is a really rich graph which can be used for generative applications. And then the generative applications are becoming a lot more high fidelity applications. They're constrained to the data, they're constrained to the medical terminology. There's less chance of hallucinations and inaccuracies and so on and so forth. And in CitiusTech, we have done that. We have built pipelines that are driven by large language models to create these graphs, and then in turn use these graphs to power generative AI applications or large language model applications that we have built for ourselves or for our customers. And there's a big component of subject matter experts who need to be also part of this entire workflow. I think what GenAI is doing is really giving them superpowers, so they can do a lot more with a lot less. And that really is the power of generative AI in building these tools for clinical decision support in this case.
Okay,
Yeah, I think
so I know that was a lot of information. And at this point, we want to go into some questions. Chris, did you want to moderate that?
Sure, I'll take care of that. That was a great presentation. Thank you, John and Kaushik. I really appreciate your knowledge and providing your expertise to our hospital members. I do have a question here. Where else have you implemented GenAI, and what has been the experience of the healthcare systems that have adopted it?
Yeah, so one that we had the privilege of showcasing with was mHealth Fairview up in Minneapolis, Minnesota. They had implemented the generative AI example and use case for IT help desk. So that's the one I was referring to earlier. We had actually did a showcase of that at a presentation at Chime, which is the CIO Association for Healthcare Systems, back in November. And this is where we had the chief medical information officer who was really leading that entire effort and actually chartering their entire AI governance up there. She had basically made the case that she does believe that this is basically a capability that they've never had before. Basically, she does believe it's worth the investment significantly, actually. Other places is there's been a number of payers, two of them that I can't share the name of, but these are one of them is a major blue that this has been implemented at. And I'll tell you what, I'm going to hand over to Kaushik to also tell a couple key examples. Kaushik, you're on mute.
Yeah, again, I'm not sure about the names, but a large medical center from the Midwest. We've done a lot of work with generative AI for their ask an expert, find a physician type of tools. We've also built workflows for discharge summaries, for hospital discharge or from ICU to other wards, relieving the burden of creating these discharge protocols with generative AI. We have been working with clinical guidelines companies to encode clinical guidelines into computable knowledge graphs with generative AI. And as a result of that, they can now interface it with their other products into Epic, into EMRs. Similarly, also care process maps. Again, with another vendor, we have built these. We've taken these care process map, which are static assets, which are documents and flowcharts and all that, into essentially computable assets, which can be plugged into an Epic system. So yeah, so these are some of the examples that we have been working on.
Hey, I have a question here from KC. He says, great presentation, great use cases. What is the technology you're utilizing? Custom internal GPTs, Copilot?
Yeah, so we are kind of agnostic to the technology. We play across different clouds, and it really depends on where our customers are. So if our customers are in the Azure cloud, then we do OpenAI, Azure GPT models. If it's a GCP stack, then we'll use Gemma, Gemini, Palm. And if we are into AWS, then the Bedrock family of models those are the ones that we use. But our methods stay the same. Whatever model we use, where we make it very contextual and very fine-tuned to the healthcare use case. And for that, we have a lot of internal expertise and workflows that we use. So we take a model which might be a general foundational model, but we fine-tune it for healthcare specific use cases.
Okay, I have another question here. What might the healthcare system landscape look like in 5 years with the adoption of AI/Gen AI?
Yeah, I'll field that one at first. And what I was reticent to mention at the very beginning is my point of view comes from being, really in the role of CIO for about 10 years for major health systems, and then Chief Innovation Strategy Officer. So that's kind of the lens that I'm applying to the answer here. I do believe that a significant amount of work is going to be taken out of our revenue cycle process. Now, that doesn't mean that we're going to have elimination of people from entire workflows. That's certainly not the case. But I believe key steps in the revenue cycle will be completely supplanted by automation, and Gen AI being a major lever of that automation. And so, that's going to radically change the central business office or the revenue cycle uh, centralized capability. What that also means is that we're going to see fewer errors, and we're also going to see much higher velocity of throughput, because the thing works 24 hours a day, weekends and holidays. Secondarily, I do see a huge impact on decision support. Why is that? That's because this technology is able to harvest a vast amount of information and basically answer the question of any administrator, clinician, or whoever, um, in a way that's like an expert. It's like a consult that they're having with another colleague, an expert that happens to be an expert in that discipline. When they do that, that gives them a completely extra set of eyes that is highly, highly capable, and really is somewhat objective based on the core data. So I think this is going to radically improve that. What that may result in 5 years or 5 years plus is being able to potentially take roles out of organizations, or having organizations only need part-time roles. In other words, a human that might be able to cover 2 hospitals or 2 facilities versus having dedicated per, as we get that kind of catalyst and tech and capability boost. Kaushik, did you have a point of view?
Yeah, no, those are great points, John. I guess the one more point I would like to make is I think in 5 or 5+ years we'll become very good at understanding disease progression, predicting disease progression. So what that will end up doing is it'll completely change the definition of risk, and we'll go more towards preventative medicine in a way that we almost can't even comprehend. So we'll be at this point in time, we'll be actually doing things which can predict diagnosis. A couple of years ago, based on all the signals from all the kind of different data sets that are going to come together, like genomics and proteomics and EHR and social data and whatnot. So we're looking at this real revolution of finally sort of tying up all these data sets and getting really good at predicting disease progression and risk management.
Okay, here's a good question here. Which use cases of Gen AI have had the highest impact on healthcare operations?
Well, the one that I've seen, actually two, I would say one that Kaushik had alluded to at a very prestigious Midwestern um, integrated delivery network, was their ability to really identify who is most excellent at a particular very specific procedure for a consult, or who could consult on that medically the best, and who's available. So let me describe what that, the kind of the as is and the previous as is, and then the how we've modified it with this AI technology. Traditionally, when you were looking for a consult, right, you kind of had this matrix that you'd go through and say, look, who do I know that's a specialist in this field? Oftentimes you went to medical school with them, or you simply know them through your network. You might have somewhat of a hierarchy or directory within your facility. But that doesn't necessarily mean that the person that may come up in that search or that query is truly the most capable, or has the most recent experience to give you the most enriched consult. But what this organization decided to do is they said, look, let's take a very objective approach. Let's pull from the actual data that's in Epic of who's done the most procedures, who's done the most with maybe these exclusive medical devices or these unique procedures. Not who's written the most literature per se, although that was part of the input, or who has been noted the most publicly, although that was part of the input, but who's actually done the stuff the most. And so when we put all of those components together, they were finding that there was a lot of people that were relatively lesser known across the entire organization that were the true experts. And that has radically improved their care model and access to very, very useful consults. Then they were able to apply kind of an availability component to that too, so that they did that in addition to our model, and now they can really get to the right person at the right time for the very granular right question. So there's one. I would also throw in this appeals letter turnaround has been very, very interesting because the payers are getting exceptionally good at denying, as you all know. And what's really going to be important going forward is the ability to understand what what was the denial criteria that a particular payer used to deny you, adapt to that, and then be able to create an appeal letter that really is personalized to that particular payer to appeal. And when you look at the different appeals letters to different payers, you'll notice that nomenclature, terms, different specific focus areas and formats, they're actually being generated differently to try to mitigate the continual claims challenge that we're all hitting. So these are some of the two high impact areas I would note. Kaushik?
No, I think, John, you nailed it. I think those are some of the ones. But we've seen some, whenever there is a cognitive burden of searching through documents and doing a certain task, that's where we get the most impact. Where GenAI's ability to search and retrieve information and put it in the hands of for example, medical necessity is one example. Aligning guidelines with procedural codes and making authorization decisions, things like that, or sending it for prior authorization. I think that's where we see a lot of impact because it's essentially taking a lot of knowledge, synthesizing it, and making it available for a clinical reviewer to make a decision.
I'll add one thing here that's, I think, notable. I heard mention of Copilot a little earlier on one of the questions. So Copilot is really essential here. Obviously, a lot of you know that Copilot's available in Excel, so as a way to completely animate how you might do search and processing of your data just in Excel alone. That's hugely important. But the thing that is a challenge that remains when we use a Copilot for a known app like that, or we use a Copilot for developing code for software, is the relevance to your particular situation. So let me take a very standard example that we're seeing. Customers are trying to use Copilot within Excel to do some basic processing and querying of their data in net new ways. The problem is because a lot of the back-end semantics have not associated the right terms with the right search terms that may be in how you have your data populated in Excel. You're getting kind of bland answers, not very useful or insightful answers. And the immediate response of the users is, this is no help. This is not interesting to me. Like, let's wait for the technology to continue to develop. When in fact, unfortunately, the people that were setting this up didn't realize that they had to do a little bit extra work to associate the backend semantics and taxonomies. And it's not a big lift, but we've seen this repetitively across so many different health systems and payers that they kind of gave it a shot using Copilot, but they didn't tweak the right things and they didn't tune the right things. And it's a massive disappointment. And we know that once you try to test this with the doctors or major administrators and they don't have a high appeal for it, that creates a bias against it. And that's unfortunate. Whereas with the right pre-tuning, which is not a major investment, you get some really surprised people with really unanticipated results, which that's where it really makes it fulfilling to do this.
Great. We had a comment in the chat from Dr. Mary Teets related to your answer to our previous question. She said, "That is so cool!" Exclamation point.
Well, thank you, Doctor. That's wonderful.
Thank you, Mary. We appreciate your positive comments. Gentlemen, it's been an extraordinary presentation. I'm going to go ahead and end the webinar. I want to see if you had any closing comments.
No, actually not. We love to support your group. We would love to come back as much as you want, and feel free to reach out to us as a sponsor now in any way you'd like to. You feel fit and comfortable, and we're looking forward to continuing to create HIT to promote healthcare. So thank you all for joining.
Great to be here. Thanks for having us.
Thank you.
Thank you so much. I wanted to let everyone know that John has been kind enough to offer me a copy of his presentation, which I will send to everyone who registered. We also recorded the event, and I will send a link once I post it online to everyone who registered. John, Kaushik, thank you so much. It's been a great presentation. I'm going to go ahead and end the webinar.
Thank you.
Bye-bye.